Consider the parallel combination of two LTI systems shown in the figure. The impulse response of the system are h1t is equal to 2 delta t plus 2 minus 3 delta t plus 1 and h2t is equal to delta t minus 2. If the input xt is a unit step signal, then the energy yt is first the overall impulse response. For two LTI systems connected in the parallel, the overall impulse response ht is the sum of the individual impulse responses. So by adding h1t plus h2t, we get the overall impulse response. So over ht is equal to 2 delta t plus 2 minus 3 delta t plus 1 plus delta t minus 2. Next, finding the output response. The output response is a convolution of the input signal and the impulse response. But input signal is the unit step signal. So convolution of unit step signal and the impulse response. Then using the shifting property of the convolution with continuous time impulse function, we get ut convolution of delta t minus t0 is equal to ut minus t0. By applying this, we get yt is equal to 2 ut plus 2 minus 3 ut plus 1 plus ut minus 2. Now we are expressing output as a piecewise function. Piecewise function has different functions for different intervals. Means we break the main function into small functions for defined intervals. Let's evaluate yt across different time intervals. For t less than minus 2, all step functions are 0. For t minus 2 to minus 1, we know that ut plus 2 starts at minus 2 and ut plus 1 starts at minus 1 and ut plus 2 will start at 2. So for minus 2 to minus 1 ut plus 2 will be 1 while other will be the 0. For interval minus 1 to 2 t plus 2 will be 1, ut plus will be 1 and ut minus 2 will be 0. For t greater than 2, ut plus will all the functions will be 1. Now calculating the signal energy. The total energy Ey of the signal yt is defined by the integration from minus infinity to infinity yt whole square. Now as the output signal is non-zero for that minus 2 to minus 1 and minus 1 to 2, we are integrating those only two parts of the signal. By integrating now we get the answer 7. The energy yt is 7 joule. This is the system's impulse response graph. Now we can see that the delta t minus 2 starts at 2, delta t plus 2 starts at minus 2 with amplitude 2 and t plus 1 starts at minus 1. This is the output signal. We get energy of the signal by integrating the non-zero portion of the signal. This last image shows how we get the output signal by adding each term. See how 2ut plus 2 term starts at minus 2 and has an amplitude of 2. 3ut plus 1 is a term that starts at minus 1 and 2ut minus 2 is a unit step function which starts at 2. And by combining all these terms we get our output signal.